The domain name system, DNS, finds the IP addresses for domain names. DNS queries, which are required to find the IP addresses for almost all websites, are unprotected. So anyone on your network can eavesdrop and modify the queries or responses. But there's a problem. There are many different DNS attacks. And they all have one thing in common. The user is being redirected to the attacker's server instead of the real website. But what would this actually look like? John, a salesman for a software company, was traveling home after seeing a client. He decided to get a head start on his expense report while he was waiting at the airport. He signed on to the airport Wi-Fi, typed in his bank's URL, www.bankofamerica.com, and carried on with his business. By the time he got home, John had received several emails from the bank informing him of fraudulent bank transfers. It turns out, when he connected to the airport Wi-Fi, it was actually a rogue Wi-Fi network, pretending to be the airport network. Once he connected, the rogue Wi-Fi network configured his laptop to use DNS servers under the control of the attacker. The attacker's DNS server sent him to a phishing site instead of the real bank website. When he entered his credentials, he was immediately compromised. So, to quickly recap, DNS hijackers pretended to be the airport's Wi-Fi network and redirected John's official bank URL to a phishing site, where he then entered his credentials, giving the attackers access to his bank account. How could John have prevented this mistake from happening? By using OpenVPN Cloud, a VPN as a service offering for DNS security. When a VPN connection is made, OpenVPN Cloud configures the DNS servers to use, therefore bypassing any DNS servers configured by the local network. As encrypted tunnel is created to transport the DNS traffic directly to OpenVPN DNS servers. With the DNS traffic encrypted and able to securely reach OpenVPN DNS servers, hijackers cannot access DNS queries and, in turn, cannot send the user to a phishing site.